Welcome back to class. We use this question to further understand how to work with electric field strength and intensity. The question says two equal and opposite charges of magnitude 2 times 10 raised to power minus 7 coulombs are placed 15 centimeters apart. What is the magnitude and direction of electric intensity at a point midway between the charges? Now, we're told the two charges are equal. That is, if I have Q1, it will be equals to Q2, and both of them, they are 2 times 10 raised to power minus 7 coulomb. Now, apart from that, we're also told that the distance between them, R, is the same thing as 15 centimeters. Since it is given in centimeters, we'll convert it to meters. That's 0.15 meters. Now, remember that electric field intensity E is the same thing as K times Q over R squared. Now, in case you missed our lesson on electric field intensity, please do not hesitate to check the description below. We'll place links to those lessons. Now, I have two charges. I have Q1 and I have Q2. I will be told that both of them are 15 centimeters apart. R, that is, here is 15 centimeters, that's equal to 0.15 meters. Now, to calculate the electric field in between them at the midpoint, that is at the midpoint. The midpoint is 0.075. That will be 0.075 in meters. Now, to calculate this electric field, I'm going to place a positive charge. We explained this in detail in our introductory lesson. Please do not hesitate to check our description for that lesson. To ensure you don't miss our lessons, please do not hesitate to hit the subscribe button and also the notification bell. That way you'll be sure you get our lessons anytime we create them. Now, if I place a positive charge here, remember if Q1, both charges, they are opposite charges. If Q1 is positive, Q2 will definitely be what? Be negative. So between Q1 and Q2, and between Q1 and my positive charge, there will be a force of repulsion. There will be a force of repulsion. So the electric field will be in the direction of the force. Let's tag this as E1. Also, between Q2 and this particular positive charge, there will be a force of attraction. So I'll have it move this way by the influence of Q2. So I have both forces moving in the same direction. Now, since Q1 is equal to Q2 and both distances are equal, that is, my Q is going to be equal in both scenario and my R is equal in both scenario. Obviously, my Q1 will be equals to E2. And the total electric field intensity is the same thing as Q1 plus E2. So that my E is the same thing as 2E1. Now let's calculate my E1. Let's create more space. Now remember that my E is given as 2E1 and my E1 is given as AQ over R squared. So that my E1 now will be the same thing as A, like we know, is 9 times 10 raised to power 9 times Q. Q is 2 times 10 raised to power minus 17. 10 raised to power minus 7. 7 or 17. Let me just confirm that, please. Minus 7. And my R is 0.075 all squared. So that my E1 is the same thing as 9 times 2 over 0.075, there's a 5 here, all squared times 10 raised to power 9 minus 7. So that E1 automatically is the same thing as, let's use a calculator, 9 times 2, now divided by 0.075 divided again by 0.075. That's 320. That's 320 times 10 raised to power 2. That one is electric field intensity, which is Newton per column. That's E1 now is the same thing as 3.2 times 10 raised to power 4 Newton. No, not 3.2, please. That's 32. 32 is 3,200. That's 32 times 10 raised to power 4 Newton per coulomb. Now remember that E, which is electric field intensity itself, is same thing as 2E1. That will be the same thing as 2 times 32 times 10 raised to power 4, which is same thing as 64 times 10 raised to power 4. Now, thank you for staying with us. Will this help you understand how to work with electric field intensity?